Hello, Vicky Pope. You're the head of climate science advice at the Met Office. Yeah. Could I ask you what you're doing here at the COP?
Well, we're here to present the latest scientific evidence. So our government, the UK government, commissioned us to do core science. A lot of it's climate modelling, some climate monitoring, and we always provide an update of that science every year at COP. We have a stand, we do a side event. So we're presenting all of that. So one of the main things that we presented this year is looking at the evidence of the state of the climate, so looking at the observations and new studies that have come out in the last year that show that the climate is warming and how the climate is changing.
So what kind of results have you presented?
Well, the first result is really that each decade, for the last 50 years, each decade has been warmer than the last. And even when you account for uncertainties in the observations, you can still see that very clearly. So we're seeing a very strong signal of warming. The second thing we looked at was indicators of warming, where not just temperature, but so as well as the atmosphere temperature, the land temperature, the ocean temperature. We've also looked at the amount of moisture in the atmosphere, the amount of water in the atmosphere, and all of those things are increasing, and that's what you'd expect with global warming. There are some things that you would expect to decrease with global warming, and that's indeed what's been happening. So we've seen the stratospheric temperature, so temperature high up in the atmosphere goes down while the temperature low down goes up. The glaciers are melting, the sea ice is decreasing, and the amount of land ice is decreasing. So all of these things add up to a complete picture of what's happening to the climate.
And what does that mean for next year in terms of, will you be presenting the same results but a year on, or will you be looking at other areas?
Well, I think we'll concentrate again probably on the observations and looking at what's happening. But we're also, as part of the material we're providing, we've also been looking at our latest climate model. So we've just developed what's called an Earth system model, which includes not just the atmosphere and the ocean, but also other elements of the Earth system that we'd looked at before, but we hadn't put them all together. So things like the carbon cycle, which is how the plants and ocean biology actually absorb carbon from the atmosphere. Now, in the future, we expect that process to decrease, and so we can get this, what we call a positive feedback, where we get increased warming. We're including other things like chemistry, which affects the makeup of the atmosphere, and aerosols, which actually cool the atmosphere. We're putting all of that together, and we're running these models for the next IPCC report, which is due out in 2013. And so those results will form the basis of that. And what we've presented this week is just the first results from those models, and some, to give people an idea of what's coming out of those models. So next year, I hope we'll have a lot more results, and we'll be presenting those.
So what is coming out of the models?
Well, there's a couple of areas that we focused on particularly. One was black carbon, so this is soot that's produced as part of the aerosol mix. Most aerosols cool the climate, but black carbon warms it because it's dark, it's black, and it absorbs sunlight. And so we need to look at the implications of that. And one interesting aspect of that is that if the black carbon is produced at high latitudes or near mountains, it can actually end up being deposited on snow through rainfall or snowfall. And of course it darkens the snow. And that means that the snow then melts more quickly because it's dark. Because obviously if snow is white, it reflects a lot of sunlight. As it gets darker, it will absorb that heat and melt more quickly. And so you get a feedback where the ice melts more quickly. So actually it has quite a disproportionate effect in that aspect, as well as warming the atmosphere directly. So these sorts of processes, you need a complex model to actually get to grips with the numbers and how important the process is. Another aspect we've looked at is ozone, which is, as well as being a greenhouse gas, also is an air quality pollutant. So it affects human health and it affects plants. And there's some very complex interactions that go on with ozone that we need to understand if we're going to get the legislation right in terms of what we need to do to combat greenhouse gases, and which greenhouse gases we need to decrease and how quickly.
Could you explain this complexity?
Well, I'll try. There's something called nitrous oxide, which, when that's produced, it increases the amount of ozone in the atmosphere, but it also decreases the amount of methane in the atmosphere. So when you reduce it, you reduce the amount of ozone and increase the amount of methane. Now, methane is a greenhouse gas as well, so those two things compete. So if you reduce the ozone, that's a good thing, but if you increase the methane, that's a bad thing. So when that work was originally done on this, they suggested that decreasing the nitrous oxide would actually increase global warming. But if you also take account of the fact that ozone has an impact on plants and just damages plants, and you then think about the fact that those damaged plants can't absorb as much carbon dioxide, which will then mean that that will increase global warming. So if you reduce the NOx, that reduces the amount of ozone, it reduces the damage to plants, and reduces and increases the amount of absorption of CO2. So when you take account of all of those processes together, it turns out that reducing the nitrous oxides actually is a good thing, and it reduces global warming. But it's only by looking at all of that complexity, which is quite difficult to explain, but it's you have to understand all of that. So this is why the science is needed to look at those sorts of issues.
And then getting that complexity mirrored in the right policies.
That's right. So once we have, we need to do the science. Then policymakers need to understand that science, at least at a level that they need to for policy, and then they can look at what policies they need to put in place. But what it illustrates is that climate change policy and air quality policy are actually linked through these sort of scientific elements.
So the natural next step would be for the two areas to link up a lot more when they're creating
That's
policies.
correct. In fact, our Department for Environment, Food and Rural Affairs published a report a few years ago where they looked at exactly this. So they took this kind of scientific evidence and they made it clear that actually they did need to link up those policies. So governments are becoming aware that this is an issue. So.
In terms of how much science does influence policy, could you explain to me the steps that this happens? Because I'm not, from my point of view and from the point of view of a lot of people here, it doesn't seem to be happening in the way it should be happening.
I think that's possibly true to some extent. I mean, in the UK, I think we have a very strong position on this. The Hadley Centre was set up as part of the Met Office 20 years ago, actually this year, and it was set up to provide policy relevant science right from the very beginning. And so we've always had a very strong link with our Department of Environment. It's now the Department of Energy and Climate Change. They obviously don't. They say these are the questions we want answered, and we gear our science to do that. They obviously don't tell us what answers to get. The answers are science, but that means that we have that strong link between what the science is and the policy, the UK's policy. We have in the UK a committee on climate change which actually scrutinises the Climate Change Act, which is used in the UK, and that again is very evidence based. So they've commissioned some work from us to look at the latest science and to use that as the basis of the recommendations that they're making. So in fact the same evidence base is being used both by the government and by the body that's scrutinising the government. They obviously are independent in their policy discussions, but in terms of the evidence, they use the same evidence because, of course, they should be using the most up-to-date reference in both cases. So those are the sorts of ways that it happens. We also have another programme which is called Avoid, which is about avoiding dangerous climate change. That's a much smaller programme, but what it does is it draws on our main climate science programme and other climate science programmes in the UK and increasingly internationally, and looks at what the implications of those are for policy. So policymakers come up with very specific questions which they then answer. So that's another way of getting a much more direct link between the scientists and the policymakers. So in fact the analysts working in government work quite closely with our scientists in this area. So.
And so in terms of how this influences international governments, how closely do you work with them?
Well, we work obviously very strongly through the IPCC, so we have quite a number of lead authors and coordinating lead authors within the Met Office. We always have, and the influence of international science really comes through that, as that reports formally to the UNFCCC and to the World Meteorological Organization. So that's one major way that we influence things, because it's important that we have an overview, an objective view of the science, and so internationally that's kind of the best way to do that, really.
And how do you feel that the COP's gone for you?
Well, I think certainly that there is a recognition that it needs to be based on the science. Of course, there are many other issues that people are discussing here, but the question of what temperature target we need to be aiming for in terms of reducing emissions is very much central, I think, to the talks. And I think that indicates that science is, when it comes down to it, is central to what's happening here. And sometimes it's difficult to remember that when you see all the other things that are going on. But, okay.
Vicky, thank you very much for your time.